你的泪光，柔弱中带伤，惨白的月弯弯勾住过往。夜太漫长，凝结成了霜。是谁在阁楼上冰冷的绝望？雨轻轻弹，朱红色的窗。我一生在纸上，被风吹乱。梦在远方，化成一缕香，随风飘散你的模样。菊花残满地上，你的笑容已泛黄。花若人断肠，我心事静静躺。北风乱，夜未央，你的影子剪不断，徒留我孤单在无眠成双。花已香完，飘落了灿烂，凋谢的世道上，命运不堪。愁墨渡江，球心拆两半，怕你上不了岸，一辈子摇晃。谁的江山，马蹄声狂乱，我一生的戎装，呼啸沧桑。天微微亮，你轻声的叹，一夜惆怅，如此委婉。花残满地上，你的笑容已泛黄。花若人断肠，我心事静静藏。北风乱，夜未央，你的影子剪不断，徒留我孤单在路边成双。菊花残满地上，你的笑容已泛黄。花若人断肠，我心事静静藏。北风乱，夜未央，你的影子剪不断，徒留我孤单在无眠成双。
走吗 via via， 易碎的骄傲着，那也曾是我的模样。沸腾着的，不安着的，你要去哪 via via？ 谜样的沉着的故事，你真的在听吗？我曾经跨过山和大海，也穿过人山人海。我曾经拥有着的一切，转眼都飘散如烟。我曾经失落失望失掉所有方向，直到看见平凡才是唯一的答案。我曾经毁了我的一切，只想永远的离开。我曾经堕入无边黑暗，想挣扎无法自拔。我曾经像你像他，像那野草野花，绝望着也渴望着，也哭也笑，平凡着。我曾经跨过山和大海，也穿过人山人海。我曾经拥有着的一切，转眼都飘散如烟。我曾经失落失望失掉所有方向，直到看见平凡才是唯一的答案。我曾经毁了我的一切，只想永远的离开。我曾经堕入无边黑暗，想挣扎无法自拔。我曾经像你像他，像那野草野花，绝望着渴望着，也哭也笑的平凡着。我曾经跨过山和大海，也穿过人山人海。我曾经问遍整个世界，从来没得到答案。我不过像你像他，像那野草野花，冥冥中这是我唯一要走的路啊。时间无缘如此这般，明天已在
升起。昨天的梦在今天重聚，为历史写下永恒的诗句。像钢铁的心，穿过烈焰，在火中升起。昨天的梦，在今天重聚，为历史写下永恒的诗句。我们的心，像钢铁的心。生命有尽，而希望无尽。用我热血，再一次奋起。就算无名，也顶天立地。就算无名，也顶天立地。
Hello guys, and welcome back to another video. And today we'll do something a little bit different than usual. So usually I would usually have some sort of PowerPoint that we go to in reference to, but this time, mainly due to time constraints, I will be trying this method. It's a method that a lot of people generally do use in like a lot of videos I watch. Like they just have the blackboard and that's kind of it. So I'm gonna give that a try to see how well that will be compared to doing the slides and stuff. You know, seeing if it's gonna be a bit more worthwhile, especially since making the slides is very time consuming. So this might be a better alternative to depending on how well it will go. So yeah, sit tight, relax, get a drink. Hopefully you did, and have some sort of notebook, pencil, paper, and anything you can use to refer while we discuss. And of course, as the title is, this is about Riemann sums and integrals, both definite and indefinite. All right. Oh, excuse me. So let's see. So we got 2 people watching right now, and so yeah, it's fine. Excuse me again. We shall begin. So we shall clear the whiteboard, or blackboard in this case. No chalk though, sadly enough. So the first thing I want to go over is Riemann sums. Okay, so Riemann sums is a very general idea. So you would have a graph, right? Let's say this is your hypothetical graph, right? And wherever that is, okay? Let's say this. So you have your point A and your point B, okay? And hold on 1 second. Okay, yeah, it's fine. I think I'll be fine. Okay. Just my light kind of went out for a little bit. I think I'll be fine. It's okay. It's okay. Okay. Actually, hold on. This is okay. Hold on. Actually, give me a minute. I gotta go fix that. But yeah. So think of the graph and think of how to find the area while I'm gone. Okay. I'll be back. Let's pause. Okay, there we go. Mute. Okay. I think it's fixed. All right. If it starts blinking again, I'm just gonna, unscrew it, unplug it, and just fix it afterwards. Hopefully I have better luck later. Okay. So okay. Also, while I was fixing that, got my calculator. It's charged. And okay, yeah. Hold on, let me just turn my light off. This isn't working. Okay. And I'm in the dark. Okay. Woo. Hold on, let me get my flashlight out. Okay. So, today we're gonna discuss about as I said, Riemann sums, definite integrals, and indefinite integrals. And so to begin, oh, that's okay. Nothing. Alright, so to begin, we will discuss about, this thing right here. This is what we're trying to find through Riemann sums. The area of whatever this is. Let's say your f of x, right? Or your function is, let's say, x squared plus 1, okay? Very simple example. And you want to find this right here, your area, and it goes from point A to point B. So how do you find it is the real question, right? Well, alright, so for people who are in my class, if you guys are here, comment down below, and in the live chat, I don't think anyone's here, but just comment down below and just say, what would you do? I'll give 1 minute as I write it out. Do not look at the screen if you're trying to think of it, just so it doesn't give it away, okay? Let's see. Okay. Yes, I know. So, this is, yes, I understand you're not in my class. Okay, so this right here is your general idea of what to do. So, you have your two distances, A and B. You take those two numbers, B minus A, the whole distance, right? Try to figure out what the whole length is from the last point, from the first point. Kind of like how you do the midpoint. You just take the 2 points that you're trying to, the midpoint. You know how you do it. Take the 2 points, subtract them like this, b minus a, the one on the right, and then the one on the left, and divide by 2. In this case, instead of 2, we have n, right here. And n is not the same thing. N is the amount of rectangles you'll be drawing. Now, Riemann sums basically consists of just rectangles in its very general form, at least. So using this example right here, the A to B one, I'm just gonna try and draw the same exact thing. Okay, and then the line, boom. So you just draw a bunch of rectangles. They're not straight, alright, but like that, something like this, right? So you have your A, and you have your B, and you use the amount of rectangles you have. 1, 2, 3, 4. That's the amount of rectangles you have. So let me just pull up one of my questions that I have written down. So let's say that the Riemann sum is asking for 4 rectangles, right? As I drew right here, you'd draw the 4 rectangles, split them up, and you would end up with that's your n. N is the number of rectangles, like that. And there you go. That's basically what Riemann sum is, at least for the beginning part. Hold on one second. Hey, bite me, hey, calm down. Bite me, calm down, okay? It's okay. She's shouting. I'm doing my last thing, okay? Oh boy. Okay. Alright, let's forget about that. But like I said, this is the whole idea of what Riemann sum is. You're given your length, the length of the distance between the 2 points that you want. In this case, it's wherever the unknown is minus the other unknown divided by the amount of rectangles you want, and that's the number of rectangles. And this right here is your general formula. B minus A divided by n is going to be the amount that you're multiplying based off of all this. So you might be wondering, what is this part right here, the whole f of whatever it is, right? That thing represents this right here. This right here. Let's say the number 4, right? This is f of whatever, right? The value of the function, the area's value of the function in this part right here. Depending on which one you use, whether it could be left or right, will determine on what f you'll be using. If you use, let's say that this distance right here, A to B, is 0 to 2, right? So let me just change that. Okay, we're gonna start very simple. Just to remember, this is just an overview for tomorrow's exam. Okay, so don't stress out too much. It's gonna be just more of a refresher, right? So let's say this is 0 and this is 2, right? Depending on which side you're going to be using, that will change your f value, especially for this part right here at 4. So if you're using the left, you'd start from here, 0, and then 0.5, 1, 1.5, and you'd have f of 1.5. That's for the left. But if you're using the right, it would be f of 2. Now, you might be wondering, where am I getting these numbers? The 1.5 and the 2, right? That's a good question, actually. And I will show you. So I'm going to clear that. You can always go back to it, to write down. But back to this thing right here. B minus A over n, right? Let's say your n, like earlier, is 4. You want 4 rectangles. And your distance goes from 0, 2. Right? This right here is your A. And here is your B. Okay? So if you do 2 minus 0 divided by 4, that equals to 2 over 4 or 1/2. Okay. And this 1/2 right here is the distance from each single point that you're working with. So if you go back to that example that I drew, very bad slant, and very general, but like, you have this 1 line, 2 lines, 3 lines, right? You have 1 interval right here. This distance right here is 1/2 of 1/2. Okay? This distance is 1/2. This right here is also 1/2. And this final stretch doesn't change. It's going to be 1/2. That's your distances from each single point. From one point to another. From 0 to 0.5, 0.5 to 1, 1 to 1.5, and 1.5 to 2. And that's how the whole idea will be working. And this is the basis of what Riemann Sums is about, in order to find the area of whatever this is. Remember, this is going to be the function that we'll be using. So f of x equals x squared plus 1. This is going to be our function, at least for the beginning part, to explain about how to do this process. And so we let me just check the chat. See anything good? Okay. Just want to make sure that everything's on top. We're good. We are clear. Okay. So the next part that I want to talk about for the Riemann sum is the actual finding of it, and it's very, very, very simple. In fact, there's a way you can do it on your calculator as well. And thank goodness, this is like my calculator is actually in my room, so I didn't have to actually run downstairs and get it. The light bulb I did have to though, and it didn't work. So now I'm using a flashlight, but that's okay. So, like I said, f of x is equal to x squared plus 1. This right here is your function, and our domain that we're going to be using is 0, 2. Okay, hope that makes sense. And our n will be 4. So if you are not allowed to use a calculator, right, first of all, put your calculator on the side and out of your reach. Okay, next thing, I would want you to draw this right here. You're going to draw it, you're going to write this out, b minus a over n, right? And I messed that up. Oops. Okay. Let me finish this. Okay. There we go. Okay, let me write that back. Okay, so n. There we go. Okay, so right here, this is your thing right here. That's how you're gonna find your the height. Okay, this is your height right here. So you might be wondering, what's this height thing, right? The height is the whole thing I showed you earlier with this. This is your height right here. If you don't remember, if you remember how to do your rectangle stuff, right? It's your base times height. Your base is based off of your f of x function. Okay? So let's say f of 0, right? F of 0 equals, and you plug in 0 for x. 0 squared plus 1. Okay? So your so that means f of 0 equals 1. This is your base. Okay? That's your base. The other one that you have to do is height. Now this is your height. This is how you find the height right here. b minus a divided by n, which in this case is 2 minus 0 over 4, which equals to 1/2. And this right here is your height. That's why the Riemann sum rectangle like system that they create, that this guy created, works, because you're making a bunch of rectangles right here. These are all rectangles. You can make these are all gonna be rectangles, right? So why not just use the area of a rectangle since you're trying to find the area of this whole thing? You know what I'm saying? Base times height. Very, very simple. Now, this is where the easier stuff. This is when it starts getting more easier once you start understanding this general concept right here. So you have your height, which is 1/2, and your f of x function, x squared plus 1, and your domain 0, 2, and boom, like this, right? Now you're probably wondering, what's the, if this is, your half, you have this, I showed you how to plug in the 0, and that's your f of 0. This is when you start writing out the actual formula, well, quote unquote formula, depends on, what you can be using, but we're gonna do this written out, mainly because there will be times when you'll have to do it, done by hand instead of on the calculator. At least with the calculator, you can do the calculations and then put on the paper, when you're given the calculator. But if you don't have the calculator and you know how to do it on the calculator but not on your paper, that's going to be an issue when you take your test. So this is the general. So this is your A, right? Because you're finding the area. Don't forget. This is the whole point of the Riemann sums, is to find the area under the under the slope. The area under the slope. So you have your area, and you're gonna put, and so you have 1/2, right? Your height times your base, which in this case is f of 0 plus 1/2, right? Your height again times the base. What? Hold on, I messed that up. I wish I had an eraser, or at least a bigger one. This is as thick as this marker gets. Okay, there we go. Okay. So, and you continue the process. 1/2 f of 0.5, and so on and so forth. Alright, up until you get to the last one. 1/2 of f of 2, and then you're done. Now what you do is plug it in. I'll give you 15 seconds in order to solve this equation. Oh wait, hold on. Wait. My bad. My bad. This is bad on my part. Hold on. This right here. Hold on. I gotta show you the other part of the concept. But okay, so this should be 1.5. This is the last one for 1.5. My bad. My bad. I'll give you another 15 seconds for that. Okay. And oh yeah. There we go. 7.5 square units. I hope you you know, understand what understand how I got that 7.5. So you plug it in, you plug everything in, right? Actually, wait. Hold on. 3.75. My bad. My bad. 3.75. Oh, Jesus. Ooh, man. Okay. I didn't. Okay, so yeah, don't forget to add the 1/2 part. But yeah, it should be 3.75. Wait, or is it 20? Oh, is it 75? Hold on. No, it's 20. Okay. Okay. Yeah, 3.75. Alright, right there. That's your answer. 3.75 square units. Now, the whole process is fairly simple, and it's fairly easy to mess up too. But you will learn to get the hang of it. So to do it, you'd multiply f of 0. So you plug in 0 for f of x, and you get x 0 squared plus 1, or 1, multiply it by 1/2, and you get 0.5. Then you do the same thing for f of 0.5, 0.5 squared plus 1, 1.125. Well, actually, hold on, let me make sure that's correct. Actually, I'm thinking about 125 with something. What? Wait. Okay. Okay. Alright. When you plug in f of 0.5, 0.5 times 0.5 is 0.25 plus 1, 1.25. Okay? Oh my god. Okay. And then you do f of 1. Plug in 1. 1 squared is 1 plus 1 is 2 times 1/2, and you get 1. They do the same thing for 1.25. I mean 1.5. Okay. And 1.5 squared is 2.25, and then you add 1, right? Which gives you 3.25, and divide by 2, or 1.625. Okay. And once you add them all up, you should get 3.75. Now, you may be wondering, hey, Sebastian, what about the 2, right? How I put the 2 by accident? With, you know? Now that part is another concept. This right here is what you call left Riemann sums. This is the left version right here. You use it using the left method. You start at 0, then you climbed up 4 times, right? 0, 0.5, 1, and 1.5. Now we're going to discuss about the right Riemann sums. Like I said, if you understand the base concepts of Riemann sums, it will be much easier to understand the whole idea of the left Riemann sums, the right Riemann sums, midpoint, and trapezoid. So the next one right here we're going to discuss is the right Riemann sums. Same function, f of x equals x squared plus 1. Okay? Okay. Hope that makes. I hope this that so far is making sense. And let's put that back. Okay. And so this is your function, and you get, same thing, b minus a over n, and the n is the same thing, is equal to 4. So therefore this is 1/2, And you do the same thing with the area, but this time, instead of putting f of 0, we're gonna skip 0, right? We're gonna skip the first part, which is 0, and move on to the second part of the interval, 0.5 or 1/2. Now, why do you ask? When you do the Riemann sum, okay, I will use x squared as an example. Okay, once I make sure that once I know that I drew it right, it should be increasing up. Okay, I'm not saying it does increase. So when you draw your x squared plus 1, right? There's your x, here's your plus 1, and it goes like this, right? When you do the left Riemann sums, it's right here, nice and even, right? You basically draw your stuff from the left, see? Like that. Now, you cover these parts here at the bottom, but you're missing those parts right here. Like that little dot right there, a little bit right there, a little bit right there. Left Riemann sums is why it's considered a underestimate. You're missing out on certain sections. Joe colored. So here, oh, that's a bad color. One. Like here, here, and here. Those, those parts right above. But also, you're drawing it from the left. You're starting from. Let me just change the color again. Okay. So you're starting from 0, right? Going to the left. Starting, and then next part, 0.5 up to the left, and then 1 up to the left. Do you see that pattern? Right? Makes sense. You start from the left and keep moving to the left up until you get to your fourth one, because in this case n is 4. Up and then over, right? But with the right, let me find a different color. Okay. But here's the thing: with the right Riemann sums, instead you start from the other side on the right, up and over. Boom. And then up. Oh shoot! So it was supposed to be up. That's okay. Up, down, and instead you start from the slope. Down, up, and over, like that. And when you move it over in this direction, you end up, from here and here. 1, 2, 3, 4 points. Still 4 points, and it combines with the n equals 4. But instead, this is rather an overestimate, and I'll show that part afterwards. Now, let's get back to the actual problem. Okay. So A, and you get 1/2 times 0.5 plus all the other stuff, and then ending with f of 2. Now, hold on, 1/2 of f of 2, and that looks horrible. Arm fell asleep. Okay, so excuse me. Okay, so next part, I'll give you 15 seconds to figure this out. Okay. Did you guys finish? So plugging it in. This is what I got. And then you put the square units thing. Okay. Done. Alright, there you go. 5.75 square units. And that's my official answer. I don't think I got that one wrong. Okay, okay, just make sure the live stream is working. I hope that, whatever you're hearing is what I'm actually saying. Because earlier I think I had an issue with the music. nice hot tea. Tea's good. So, this right here is what you should have gotten. 5.75 square units. And I will clear the whiteboard, and I'll explain why this whole thing is, how this whole thing works, right? So this is your 1, right? Goes up that way, and it goes up this way. Don't worry about this part. Don't worry about that. Okay. Focus on the right side. So we have our 4 points. Yeah. Like that. Okay. And I will discuss the left first. So with the left, you start here at 0. You go up until you hit, you know, the edge of the of your, I guess you could say, base. Well, side. I guess you could say side. Okay, I think that's fine. But you go up to the side, right? You begin on the left, and you cross over once you hit that part. This is what you just calculated with your f of 0, right? 1 second. I'll write down the function. F of x equals x squared plus 1, right? Now remember, when you did f of 0, you did this area right here. You did not do this little spot right there. That spot was not calculated. Okay? Then you move up, right? Up the thing again. Boom. Another one. This right here is we calculated for 0.5. And again, you're missing on part of your area. Then you just keep going, right? This right here, f of 1. This should have been 2, I believe. And again, you're missing more of your you know, of the area under. Then your final 1.5, and boom, there you go. You cleared all 4 rectangles that were needed. Remember, n was 4, not 5. That's why we're not going to f of 2. And again, you're missing part of the area. Now this is the whole reason why whenever you do a left Riemann sum, you gotta make sure you say it's an underestimate. Okay? Remember, underestimate. If you rate anything, right, with an area related to Riemann sums, and you use the left Riemann sums, make sure you write that's an underestimate. I cannot fit it on the paper. I cannot fit it on my whiteboard, blackboard, whatever you want to call it. But remember, not always write that's underestimated. Underestimated whenever you write any left Riemann sums form, you know, area with the left Riemann sums. It's always gonna be, especially when you start, it's gonna be very easy, right? It's like, oh, left Riemann sums, right? Once you get to some of the more complicated ones, you're gonna have to look through a little bit more. But just in like 80 to 90% of the cases, there's gonna be a large chance it's gonna be underestimate. Okay. Now there will be some other ways you could do this. Like, let's say this is your you have your graph, and you have well, you got yourself a a nice little concave down function. Negative x squared minus negative x squared plus 4, I guess. Actually, hold on, that won't be no. Nope, no, that works. Nope, that does work. Yep. Negative function, yep, okay. Yep, it does. I'm not crazy. I'm pretty sure you should have learned that geometry anyways. You cannot yell at me for that. So let's say this is your function, right? Negative x squared plus 3 or 4, right? And you want, and when you draw the your rectangles, right? Say it like that. Actually, hold on, let me make it a bit more clear to see, right? So like links like that, right? It's like that, and you draw your left from the left to the right, right? Like this. Looks fine, but then oh, right? You see that? That right there is not an estimate. You got extra space here, extra space here, extra space here, and extra space here. This is this is the type of style that you're gonna see for your graphs, that you'll know that it will be a left Riemann sum being overestimated. But like I said, in most cases, it will be generally, it should be underestimated. That at least it'll end up like that. You can, if you're unsure, no worries about drawing a rough sketch of the graph and showing this with the whole, that with your rectangles, and showing that you have gap, wherever the missing part is. It could be under it could be under the slope or above the slope. That is fine. You know what I mean? Especially when you do open responses and you show this, right, to prove if your Riemann sum, left or right, depending, is gonna be overestimate or underestimate, or underestimate. This is a good way to show. To show your work. Of course, you're might have to explain a little bit to give reasons to what this is. If you just stop that paper in the front of your teacher test, you're like, what is this? You know what I'm saying? Gotta give a reason. You could be like, because the Riemann sum is concave down, which you can check through, I believe, the second derivative. And because it's a concave down function, according to the second derivative, the Riemann sum, the left Riemann sum, is overestimated. Okay? I hope this is making sense to whoever is watching. And remember, if you have any questions, do not be afraid to ask, and do not be afraid to bring up anything that you want. You know what I'm saying? If I'm talking too loud, if I'm speaking too fast, just let me know, because this is for a lot, mostly for you, right? It is for me too, in fact, that I am able to refine and remember what I've learned, but also it's to help you guys, and if I watch it again in the future, I don't know. You know what I'm saying? It's a win-win. I got better at doing these for you guys. More people like it. I hope you guys will like it too. And when I want to make sure that what I'm doing is actually helping. You know what I'm saying? Because if this isn't working, I can just go back and sit at my desk and just do this myself. You know what I'm saying? So, that being said, we shall continue. So, this is your, like I said, this is how the Riemann sum going on the left side, left Riemann sum can be a negative, can be a overestimate. Now, we're gonna use the same function, right? Yes, you might be bored after seeing this function for like half an hour. F of x. Who remembers it? Okay, never mind. There's like 2 people watching. Never mind. F of x equals x squared plus 1. And that right there is, the same function. But now, like I showed you with the right Riemann sum, it will be an overestimate. Now, my first question is, do you remember what you put down for your right Riemann sum versus your left Riemann sum? I'll give you 2 minutes to look at your to use this and find the left Riemann sum and the right Riemann sum. Remember, your n is 4, and the domain goes from x equals 0 to x equals 2. That's the general idea. Okay. Nice. I probably should just use this mute button more often. Okay. Gonna do calculations. See, 0 squared plus 1 plus squared plus 1 plus 1 squared plus 1 plus 5 squared plus 1 plus 1 times 25. Okay. 2.75. Okay. Okay, so right here should be the two calculations that you have gotten. Your left Riemann sum and your right Riemann sum. Now, I am not 100% sure, okay? You can ask your teachers about this. If you're allowed to use at left RS or right RS as an abbreviation or shorthand version of saying Riemann sum. Kind of like how you have this for l'hôpitals. You know l'hôpitals rule? The derivative, if the, that, actually, I'm pretty sure I went over that in the limit section, so I will, so go watch that. I will hopefully link in the description. If not, you can still find it on my channel. So, this is what it is. So, right here is your left Riemann sum, which is an underestimate, and your right Riemann sum, which is an overestimate. And, like I showed you, with the graph, right, you have your, this is the side that I want to focus on. You have your parts, and we do the right, it goes overestimate, same exact thing. When you do, same thing, when it goes downwards, right, for the right Riemann sum, say like this, it's going to end up as an underestimate whenever you do that. So just keep in mind about the direction of how the graph, the direction of the slope. Well, the derivative of the slope, the double derivative, right, of double. Oh, excuse me. When you find the f double prime, you'll figure out to see if your graph is concave up or concave down, especially if you do an open response. In this case, we have a concave up based off of the original function, and we can go further more in depth on that, but I just don't think we'll have the time, because I also want to get to the other stuff like the integrals. That's a bit more complicated work. This right here is more like a general overview, and we're going a bit longer than I had hoped, at least for this section. Mainly because I just want to be as thorough as I can. Good. X squared plus 1. Yes. Okay. So this right here is the whole. This right here is like the whole idea. Whenever you do left Riemann sum, and this is the type of graph, and you can generally just draw it out. You can see very easily though if it's going to be if the left Riemann sum or the right Riemann sum is going to be positive or negative. Not positive, negative, or underestimate or overestimate. In most cases, left will be underestimated and right will be overestimated. Just draw the graph after, if you're unsure. Just take a look at the graph. I'm pretty sure, actually, forget what's about the second derivative. I'm pretty sure you can do the same. You can still do it just as fine with the standard function. I'm pretty sure. If I'm wrong, I'm sorry. I really am. I really don't want to mislead people. That's my main concern. So, next part is the midpoint and the trapezoid. And I'm gonna switch it up a bit and use a different method on how to find it. Let me just find the this one. I think that will work. Yeah. Right here. F of x equals 2x squared plus x plus 7. A little bit more complicated, but it's still doable. You can still figure this out. And this is your range. And I'll be nice. Up one. I understand this is a bit more complicated than the x squared plus 1, but also, yes, I am not actively looking at the chat, just saying. So right here you have your that, and your n equals 4. Okay, I'll give you, actually, hold on, let me show you how to do the midpoint part. Actually, midpoint first, and then I'm going to show you the trapezoid, and then we're gonna use another one to solve that. Okay? Or you can try this out right now with the left Riemann sum or right Riemann sum, whichever you decide. I'll give you 1 minute, right, to figure it out, and it should be fine. The biggest thing, though, remember, when you have f of, let's say this is f of 0 plus f of 1/2 f of 1, and so on and so forth. This is multiplying. 1/2 times this, 1/2 times this, 1/2 times that. Just pull out the 1/2. Okay? Just pull out the 1/2. Because you're going to be multiplying that 1/2 with every single thing in the sequence. The whole sequence is going to have 1/2, 1/2, 1/2, 1/2. Depending on what it is. In this case, it's going to be 1. Right? It's going to be, yeah, it's going to be 1. See, 4 minus 0 divided by 4, yeah, 1. Yep. I'm not crazy. So, yeah, f of 0, f of 1, so on, and so forth. And then afterwards, you get all that compiled, multiplied by 1/2, and you'll get the same answer as this. You'll get the same answer. It's going to be the same answer because of how multiplication works. So, that being said, I'm pretty sure you will be. I'm pretty sure I have confidence that even if you are in, geometry, trigonometry, or pre-calculus, you can still figure this out to find the area under the slope. Especially using the Riemann sums, which is plugging in your x's or x values into the function, and then adding them all up, and then multiplying by whatever this is. Your b minus a over n. In this case, you should get 1. Okay? Now, I'll give you 1 minute to figure that out. You can choose whatever you want. You want left, you want right. Either one can be fine. If you're in my class, I'll challenge you. Do trapezoid. Alright, you got 1 minute. Okay. Okay. So your time is almost over, right? I'm gonna give you an extra minute. I'm gonna clear this, so make sure that you can go back by like 10 seconds and see it still, right? Because I'm gonna write down the answers, okay? And just compare yours with with what I got. And if I am wrong, just tell me and give me a reasoning, okay? That's gonna be left, okay? Well, actually, no. I think I messed up somewhere. Hold on. I don't. No, it's not. It's not 71. Hold on. My bad. I don't think it's 71. Let's say one. Nope. Wait. No. 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 Hold on. Never mind. We are fine. We are fine. This wrong. Good shape. Okay. I'm just continue with my calculations. And this is the trapezoid, which should be the final one. If you're in my class and you decide to take this route that I suggested. Okay. Because I really messed up that 8. Okay, that's close enough. Enough that once I redo it, it's still legible. There we go. And this right here is the like I said, if you check, if you go into your graph and you have a general idea of what the plot is, or you just base off of like a couple of your calculations. You did the calculations already. You can plot it out. Doesn't have to be accurate, but very general. You could have a very general plot and plot that. Like plot, then connect them all and up. Then do this. Do your left. And this shows, this is a good way to prove the underestimate. Same thing with the right. You have your plot, connect, boom, 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 boom. Overestimate. Trapezoid, same thing. I will discuss trapezoid after. So this should be your answer. 71 square units. 98. If you do the left Riemann sums, 71 square units. If you did right Riemann sums, 98 square units. If you did trapezoid, 82.5 square units. Now you may be wondering, what is this? I am so confused, right? Hold on. Wait. I messed that up. Hold on. I actually multiply by extra 2 on the trapezoid. That's even worse. What did I do wrong? Okay. I think I did something wrong with my calculations. So, do not trust what I just wrote. Do not. Okay. We can stop here, I guess. I don't know if anyone else is coming to watch. I still have some stuff to do, you know, so I think 72 minutes is a decent amount of time, especially the fact that a decent hour at least, right? That we did about Riemann Sums so far. And we went over the left and we went over the right. I will make a part 2 for this, right? Just because there's a lot of content. I need my sleep. You know, I'm really gonna need my sleep. Get the rest of my work done. And also the fact that I think I screwed up the calculations for these, so if you did watch this, I am sorry. Because I don't think I did it right. I really don't. I'm pretty sure I messed up somewhere in my calculations for the trapezoid. And probably the left and right Riemann sums along the way as well. So, yeah, I think this is a good place to stop for today. So, you know, don't forget, guys, do your homework, read your notes. Those notes aren't just there, you know, just to open in class, look at it in class, and be done with it, you know. Make sure you look at them at home, look at them in your free time if you feel like it. You know, it's gonna help you, especially to keep everything refreshed. Get your homework done, get it done on time, or at least most of it, you know what I'm saying? If you can at least get most of it, and then I understand if you can't get some of it because you don't understand it, you know, that makes sense. If you're not doing it just because you don't know how to, if you just because you don't want to, that's not good. But like I said, stay strong. If you're, always just stay strong. Okay? If you're if you're like 5 minutes away from victory, surrender and retreat are not an option. Never. Remember this. If you're in like the last 5 minutes of the test, don't just give up right there. Keep going. Just keep going. Alright? You hear the bell, and the teacher says, okay, you can stay a little bit extra. Stay a little bit extra, especially if you have your test out. Okay? It could be anything. Could be anything that you're doing. Surrender and retreat are not an option. When you're just 5 minutes away from victory. Don't give up. Don't celebrate too early. That's one of the worst things to do is celebrate too early. Because then you'll lose even more. So, that being said, I hope you guys enjoyed. I'm sorry for what happened. I'm pretty sure I messed up the stuff somewhere in it. And let's see what's a good outro music. I can play this one again, the Pushu one, the content. This is a good one. Or actually, hold on. Here we go. This is Leslie Chung and the song Running Toward the Future. Hope this is my little outro song. Here. So you guys can leave now. Or you can just stay and listen to this one song before I end the video. Okay? And if you are leaving now, hope you guys enjoyed. If you're staying for the outro music, thank you. Leslie Chung is a very great singer, and I appreciate it that you too will enjoy the song. So thank you guys for watching, and I'm really sorry.
無謂問我今天的事， 無謂去知，不要問意義，有意義冇意義，怎麼定判？不想不記不知，無謂問我一生的事，誰願意講失落往事？有情無情，不要問我，不理會，不追悔，不解釋。
Next video.
意思無淚無語。
Okay, no. Okay, this is the same music video. Here. Yeah, I'll play it like that. I think you'll like that better.
無謂問我今天的事，無謂去知，不要問意義，有意義冇意義，怎麼定判？不想不記不知，無謂問我一生的事，誰願意講失落往事？有情無情，不要問我，不理會，不追悔，不解釋意思。無淚無語，心中鮮血湧出不願你知，一心一意奔向那未來日子，我以後陪你尋覓好故事。無謂問我傷心事，無謂去想，不再是往事。有時有陣時不得已，中間經過不會知，不會知。無謂問我一生的事，誰願意講失落往事？有情無情，不要問我，不理會，不追悔，不解釋意思。無淚無語，心中鮮血湧出不願你知，一心一意奔向那未來日子，我以後陪你尋覓好故事。無謂問我傷心無謂去想，不再是往事。有時有陣時不得已，中間經過不會知，不會知。
elevating you, where 93% of graduates.
Alright. Thank you guys for watching.